Andrew King's work represents a monumental effort to unify quantum mechanics, general relativity, and the Standard Model into a single framework. Through mathematical rigor and empirical testability, his journey has led to breakthroughs in understanding space-time, quantum gravity, and cosmic evolution. This narrative captures his groundbreaking path from quantum field theory foundations to the revolutionary unified geometric wave theory. King's journey began with a deep dive into quantum field theory, the backbone of the Standard Model. By meticulously analyzing the behavior of the electromagnetic, strong, and weak forces, King uncovered their unique traits governed by gauge symmetries. In QED, governed by U1, King demonstrated how the lack of gluon-like self-interactions allows electrons to remain unconfined. In QCD, governed by SU3, he elucidated how gluon self-interactions explain both asymptotic freedom at high energies and core confinement at low energies. His beta function calculations and exploration of Wilson loops added mathematical precision to these discoveries. These insights into gauge symmetries and force behaviors became the bedrock for extending these principles into the realm of quantum gravity.
The next phase of King's work delved into the heart of space-time itself. He proposed that space-time isn't a smooth continuum, but emerges from a network of quantum-entangled gravitons oscillating with gravitational waves. King's framework redefined the Einstein field equations by incorporating quantum corrections. These corrections stabilize space-time at extreme densities, preventing singularities and instead creating finite, structured geometries. This vision ties space-time curvature to quantum interactions, where the quantum foam at the Planck scale acts as the medium through which gravitons operate. It's not just a theoretical construct. This framework predicts observable phenomena like specific gravitational wave signatures. In an unexpected turn, King's equations began describing objects that he later identified as Planck stars, ultradense remnants formed when quantum gravity halts gravitational collapse. Unlike singularities, Planck stars represent stable endpoints where quantum pressure counters gravity at critical densities. These objects, residing in black hole cores or formed in the early universe, offer solutions to major puzzles in physics. For example, they could account for certain dark matter phenomena due to their gravitational pull without emitting light. King's numerical simulations confirmed their stability and characteristics, aligning with high-energy observational data like gamma-ray bursts, further validating their existence. A key breakthrough in King's work was the concept of primordial emergent coherence, PEC. This theory describes how quantum fluctuations at the Planck scale generated coherent structures that influenced cosmic inflation, large-scale structure formation, and even black hole dynamics. By refining the Klein-Gordon equation with quantum corrections, King showed how PEC organizes early universe quantum fluctuations into observable imprints in the cosmic microwave background and galaxy distributions. PEC also explains the role of quantum corrections in inflation and ties directly to dark energy as an emergent property of the quantum foam, providing a unified view of the forces shaping the cosmos. King's work went beyond theory to produce testable results. For example, his quantum-corrected Friedmann equations describe phases of cosmic acceleration, from early inflation to present-day dark energy-driven expansion. These corrections predict unique patterns in the cosmic microwave background and specific gravitational wave echoes detectable by observatories like LIGO and LISA. King's research culminated in the Unified Geometric Wave Theory, or UGWT, a comprehensive framework integrating quantum foam dynamics, PEC, spin networks, and the Standard Model. UGWT resolves the incompatibilities between quantum mechanics and general relativity, providing a pathway to the elusive theory of everything. The theory posits that space-time emerges from quantum geometries governed by graviton interactions, while the Higgs field and dark energy act as crucial components of this emergent structure. UGWT also refines the quantum-corrected Einstein field equations, offering solutions to problems like singularities and cosmic inflation. Andrew King's work represents more than academic progress. It's a paradigm shift. From the discovery of Planck stars to the unification of cosmic and quantum phenomena, King's theories open new doors to understanding the universe. With empirical validation and predictive power, The unified geometric wave theory brings us closer than ever to a complete understanding of the cosmos. Andrew King's legacy will forever be a cornerstone in the pursuit of scientific truth.